Hello, ladies and gentlemen. This is David Taranki, and this is a proposal for my UI 443 class. I'm working on determination of heavy metals and fish from Mississippi. So, introduction. Mississippi River is very well known for mining industry in 1800s and early 1800s to late 1900s, where a lot of smelters. It was easy to transport a lot of metals and minerals across Mississippi down south to the bigger cities. Essentially, so the mining industry the popular mining industry also caused a lot of heavy metal contamination, like smelters, and essentially this causes bioaccumulation. The bioaccumulation, uh, what it means is the bigger the surface of area is, the higher the concentration that are going to be accumulated in per body, where the ecosystems are. So the ecosystems, so the fish and the river uh, usually take up all the metals. So one of the most popular fish in Mississippi are catfish, largemouth bass, bluegill, and crappie. And these are the most popular fish that people from southern Illinois and southeast Missouri. So essentially, this project is going to be based on the fish that are popular around this area and the concentrations that are going to be found using the methods that I'm going to talk about. So bioaccumulation, I just explained how it worked. The metals that are being released into the river are where the fish get contaminated by absorbing all those metals through the water and whatever they eat. So a little bit of background, why we want to test for the heavy metals. The six heavy metals we're testing are going to be arsenic, lead, cadmium, mercury, methyl mercury, and chromium. These are our Obviously these metals are going to be present in our body at like a tiny concentrations, but higher the concentrations, they are very dangerous to human life, to ecosystem as well. Arsenic at higher concentrations can cause blood poisoning and bronchitis. Major sources for arsenic are pesticides and smelters. Like I said, there are plenty of smelters along Mississippi, and the other metals like lead. So lead is great at acting like calcium. So lead binds like calcium in our body, and higher lead concentrations can uh, cause bone deformities in people, in fish. Essentially, uh, in early 1800s, we used to use lead pipes, and that's and all the water through lead pipes caused contamination, and people started having bone deformities. Essentially, lead works just like calcium, and it replaces calcium because it's a lot more stable in our body. Usual major sources for lead are paint, pesticides, automobile emission, and burning of coal. Um, cadmium Cadmium is causes renal dysfunction, bone defects, and gastrointestinal disorders. Essentially, it's going to destroy the gastrointestines in our body. So higher levels of cadmium. Cadmium is also very dangerous. Mercury and methyl mercury, they kind of go hand in hand. Methyl mercury is a lot more toxic to our body than mercury is, but they're both very similar. They cause damage to nervous system, so slower motor skills, slower uh, reaction for most of our nervous system in our body. Chromium is very similar, acts very similar to mercury. It also causes damage to nervous membrane. So that's one of the reasons the six metals are being tested in this fish. Um, and a couple of the materials and equipment that we'll be needing for this experiment is our sulfuric acid, nitric acid, and hydrogen peroxide, where these three acids are going to be used to digest the fish tissue. In heavy metal standards, will be needed to test the concentration to be able to identify, hey, these are the heavy metals that are going to be found. This is what we can see. This is what we need to see in the fish if we're testing for the certain metals. Centrifuge tubes is to store the fish tissue, and the solutions. Micropipette is to be able to pour the solutions into it. Microwave is to digest the fish, where the fish and the solution are going to be put in the microwave, and that's going to digest the fish tissue into liquid, which will be used in the ICP OES to get our intensities for our concentrations for the heavy metals. Homogenizer is used to cut the fish up and be able to introduce it into the acids. Quartz containers will be used for microwave. Argon and nitrogen gas are very essential for ICP to work. So we'll be using argon gas to ignite the flame in the ICP. So once again, I'll go over the methods. Preparing the fish. So we'll be using a homogenizer to prepare the fish. We'll cut the fish into very tiny particles, very tiny pieces, and in the centrifuge tubes, we will introduce 1:1 nitric acid to sulfuric acid and hydrogen peroxide. Essentially, those three acids are gonna be digesting the fish for us, and the fish will be homogenized and will be put in a quartz container in the microwave for an hour at 105 degrees Celsius. Uh, so at the end, we're gonna get a solution, digested fish tissue solution, which is gonna be diluted 1:1 with water, just so that when we put this acids in the ICP, we're trying not to destroy the machine if it's too concentrated. So a dilution will be done as soon as the fish is digested. So we'll be using ICP OES to analyze our metals. So ICP is inductively coupled plasma optical emission spectrometry. Essentially, how this works is the ICP is going to have this is the ICP. So the fish tissue tubes are going to be put in here at the auto. It's called the auto sampler, where this tube will go in to the tubes, pull the sample up through this wire, and it will send the fish tissue through this column, the black column. At the black column, there's plasma, which will be ignited through argon gas, previously I was talking about. This is a very high temperature plasma, where it's going to ionize and shoot the metals through the chamber, where the spectrometer is going to measure the wavelengths of each metal at a specific wavelength, and it will show us the concentration, the intensities onto a computer. Essentially, through that we can calculate our concentrations, and one of the best ways to do it is to have a calibration curve. This is where the metal standards come into play. The metal standards are going to be used to make a dilution in nitric acid, so we'll have the same acid we'll be using for the fish. Uh, so then, so we can make 1 ppm to 0.1 ppm standards, 5 standards, and we can test them, make a calibration curve, and the equation we'll get is y equals to mx plus b, where y would be the intensity, and we can calculate the concentration at x. So x equals will be the concentration. Some results and expectations probably our metal concentrations milligram per gram of fish tissue. Excuse me. You're expecting less concentration, smaller fish. Again, by accumulation, the smaller the fish are, the smaller the materials are, subjects are, the less concentration is what you're expecting. The bigger the fish, the bigger, the higher the concentrations are going to be. A couple other things we could work on, and expectations would be spiking methods. We could spike the fish at a known concentration of metals, and at the end we can subtract all those concentrations out, and that would give us the amount of concentrations that are still left in the that came out as a result of the fish. And the reason a lot of people do that is because they're very tiny concentrations, but they are very toxic. So to increase the detection limit, so when we add a spike, we increase the detection limit for the ICP, and it's easier for the ICP to find the intensities which are a little higher. So essentially, when we spike the known amount, the end we can take it out, and whatever's left would be the concentration that we'll be getting. Couple of safeties is we're going to be working with sulfuric acid and nitric acid. Obviously, they're very concentrated acids, so obviously we want to be careful. Hydrogen peroxide, same thing. It's a concentrated hydrogen peroxide. It's an oxidizer. So you don't want an oxidizer in your body. Heavy metals, You do not want the heavy metals. You don't want to have a skin contact with the heavy metals, even at tiny concentrations, because they are very toxic to our body. So goggles and lab coat all the time. We'll be working with ICP, which is a higher temperature. We were working with higher temperatures, so uh, just being careful around the machine. Some future experiments that could be done if this is successful is fillets of fish. So how many fillets it takes for a human to reach the standard limit? How many fillets of fish they could eat which is contaminated with those metals? Something that could be done in the future experiments. Smaller fish could be tested where there's catfish and crappie where they eat the small fish. So the small fish can be tested. How much concentration do they have? And something else we could also do is original metals. So we can trace where these fish are coming from and find where the toxic metals are being led into the river. And a couple of acknowledgements, Dr. Cynthia Chu, Dr. Adam Jacoby, Dr. Phelps, Dr. Herzog, who work with the Missouri Department of Conservation. This project would be a part of Missouri Department of Conservation because they are the guidelines of all the things that happen on the river, along the river, and Dr. Mike Rogers for helping through this proposal that I'm currently working on. And here's the references that I had a chance to compile the data from, compile the techniques from. So big thank you to them. And if you have any questions, email me at atanikiwanes@cima.edu. Thank you for your time.